So if we know, we will continue some more discussion on distributions. We have known that if we know the probability mass function of a random variable, you can calculate anything related to that random variable, like expected value, which is called as E, or variance. If x is the random variable, then probability of x is equal to little x is the function of x, which is nothing but the probability mass function. Expected value of x is the sum of x fx, which is nothing but sum of x into xp, which is xp is the expected value of x, and or x is whatever the function of x is, whatever the pm of x is, and you just sum all those expected values to get the function of x, and then to get the expected value of x. Because this is, as we had looked at into the dice, then you get the values 1 2 3 4 5 6, and then you multiply by the PMF of each of them, which is going to be 1 by 6 in this case, which is nothing but fx. So it is a weighted average, and the way to weight the average would be 1 times fx, where x is equal to 1, plus 2 times fx, where x is equal to 2, and that's exactly what we are doing here. It is sigma x fx is the expected value of x. And then we have also looked what the variance is. The variance of x, and this equation comes again and again, is expected value of x square minus the expected value of x square. Then we had talked about binomial and geometric distributions. So if a random variable x has a PMF of fx is equal to 6 by pi x square, and x is equal to 1 2, then the probability that x is more than 2 but not greater than 4 is, what it just means is more than 2 but not greater than 4, that it 3 and 4. So all you do is you calculate the PMF of 3 and 4 and then add them together. So that is probability of x is equal to 3 and plus probability of x is equal to 4, and we already know the PMF formula. So that is 6 upon pi 3 square, or pi square 3 square, plus 6 upon pi square 4 square, and you will get the answer. Now another question can be probability that a fair coin will need at least 3 tosses to produce a first head can be expressed in terms of binomial with a parameter of n is equal to 3 and probability of half, because we know that 3 tosses, so n is 3, and what is the probability of head in 3 tosses. And it can also be expressed in geometric where the parameter now is going to be still is half over values 0 to 3. So to calculate for 0, 1, 2 and 3, and then you can add them up. So then and some of the other things which we have also discussed previously, expectation and variance calculation for random variables. So for random variables x, y and z, the expected value of x plus y plus z is equal to expected value of x plus expected value of y plus expected value of z. This can happen whether or not they are independent. But if they are independent, then variance of x plus y plus z is equal to variance of x plus variance of y plus variance of z. But if they are not independent, then variance of x plus y plus z plus will be variance of x plus variance of y plus variance of z plus covariance of, or 2 covariance of x y plus 2 covariance of x and z plus 2 covariance of y z plus, and how do we calculate the covariance? The covariance of x and y is going to be expected value of xy minus expected value of x times expected value of y. And if x and y are independent, then covariance of x and y is going to be 0, because this is going to be the same as this, in which case all of this becomes 0. So it essentially becomes this, you just add them up.